am Dr. A S Vijayakumar, Assistant Professor, Department of Biochemistry, Engineering Department of Science. Today I am going to take mucopolysaccharides, bacterial cell walls, polysaccharides and zeolic acid. Introduction. Mucopolysaccharides are glycosaminoglycans or polysaccharides which consist of repeating disaccharide units. Cell wall. The cell wall is the outermost layer of the cell. In many cases, the cell wall comes in direct contact with the environment. Functions of cell walls are protection of the cell, maintains the shape of the cell, maintains the osmotic integrity of the cell, assists some cells in attaching to other cells or in eluding antimicrobial drugs, providing attachment sites for bacteriophages, play an essential role in cell division. Gram-positive cell, usually thick, homogeneous, composed mainly of peptidoglycan. It accounts for 50 to 90% of the dry weight of the cell wall, contains large amount of teicholic acid. Special components of gram-positive cell wall is teicholic acid. Teicholic acids are connected to either peptidoglycan or to plasma membrane lipids, absent in gram-negative bacteria. Functions of teicholic acid: antigenic determinant, participate in the supply of magnesium to the cell by binding magnesium 2 plus, regulate normal cell division. In gram-negative cell wall, multi-layered and more complex than gram-positive cell walls. Peptidoglycans of gram-negative bacteria is thin and comprises only 10% or less of cell wall. Gram-positive cell wall, usually this is a gram-positive cell wall. Peptidoglycan, also known as urine, is an enormous heteropolymer. The polymer contains two sugar derivatives, N-acetyl glucosamine and N-acetyl uramic acid, and several amino acids present. Out of these amino acids, first three are not found in proteins, hence they protect against the attack of peptides. The backbone of the polymer is composed of alternating NAC and NAM residues. The peptide chain of 4 alternating D and L amino acid is connected to carboxy group of NAM by amino group of L alanine. Chains of linked peptidoglycan subunits are joined by cross links between the peptide. The carboxyl group of terminal D alanine is connected to the amino group of DAP of subsequent unit. Peptide interbranch is used in GBP to connect the adjust chain of peptidoglycans. Peptide interbranch is made up of 5 units of glycine. The cross linkage results in a sac-like structure of peptidoglycan, which is dense, highly interconnected, elastic and stretchable. This is the peptidoglycan structure. Types of polysaccharides in bacterial cell wall. Bacterial glycoproteins are lipopolysaccharides and capsular antigens which are attached by lipid anchors. In gram-negative bacteria, membrane-derived oligosaccharides, also known as the osmoregulated periplasmic glucans. MDOs are a heterogeneous family of closely related, highly branched oligosaccharides containing glucose as the source sugar. They are substituted with the SN1 phosphoglycerol, phosphoethanolamine and O-succinate ester residues. Lipopolysaccharide, made up of a lipid and polysaccharide which are joined together by a covalent bond. In gram-negative bacteria, lipopolysaccharides comprises of 3 parts. One is O antigen, and second one is core polysaccharide, and third one is lipid A. The sugars commonly present are heptose and 3-deoxy-D-manooctylosonic acid. Lipo-oligosaccharides, glycolipids which are present in the other outer membrane of certain types of gram-negative bacteria. Capsular polysaccharide, the capsular polysaccharide constitutes the outermost layer of the bacterial cell and mediates its direct interaction with the environment. Accessory polysaccharides consist of sugars like teicholic acids, ramenose, glucose, galactose or mannose. functions of polysaccharides in bacterial cell wall. Importance of glycosylation. The N or O glycosylation of the peptide in bacteria would induce the host response by causing infection. Lipopolysaccharides act as a candidate target for new antimicrobial agents. LPS generally acts as endotoxin as it binds to the cell receptor complex in monocytes, dendrite cells, macrophages, and B cells, which thereby promotes the secretion of pro-inflammatory cytokines, nitric oxide, and eicosanoids. Capsule of polysaccharide. The capsule of polysaccharides constitutes the outermost layer of the bacterial cell and mediates its direct interaction with the environment. Sialic acid. Sialic acid are class of alpha keto acid sugars with a 9-carbon backbone. The term sialic acid was first introduced by Swedish biochemist Gunnar Flex in 1952. The most common member of this group is N-acetyl uramic acid, found in animals and some prokaryotes. Sialic acids are found widely distributed in animal tissue, and later forms are found to a lesser extent in other organisms like some microalgae, bacteria, and archaea. Sialic acids are commonly part of glycoproteins, glycolipids, or gangliosides, where they decorate the end of sugar chains at the surface of cells or soluble proteins. Sialic acids have been also observed in Drosophila amphibians and other insects. Generally, plants seem not to contain or display sialic acids. This is a sialic acid structure. The sialic acid family includes many derivatives of the 9-carbon sugars, uramic acids, but these acids rarely appear free in nature. Normally, they can be found as components of oligosaccharides, chains of mucin, glycoproteins, and glycolipids, occupying terminal, non-reducing position of complex carbohydrates on both external and internal membrane areas where they are very exposed and develop. Important functions. The numbering of the carbon atoms starts at carboxylate carbon and continues along the chain. The configuration that places the carboxylate in the axial position is the alpha anomer. The alpha anomer is the form that is found when sialic acid is bound to glycans. However, in solution it is mainly in beta anomeric form. A bacterial enzyme with sialic acid mutratase activity NAN-M that is able to rapidly equilibrate solutions of sialic acid to the resting equilibrium position of around 90% beta or 10% alpha has been discovered. In contrast to the other animals, humans are genetically unable to produce the sialic acid variant N-glycolinolenic acid. Small amounts of new 5-GC detected in human tissue, however, may be incorporated from exogenous sources. Biosynthesis of sialic acid is synthesized by glucosamine 6-phosphate and acetyl-CoA through a transferase resulting in N-acetylglucosamine 6-P. This becomes N-acetylglucosamine 6-P through epimerization, which reacts with phosphoenol pyruvate producing N-acetyluramic 9-P, which means sialic acid. For it to become active to enter the oligosaccharide biosynthesis process of the cell, a monophosphate nucleoside is added, which comes from cytidine triphosphate, turning sialic acid into cytidine monophosphate sialic acid. This compound is synthesized in the nucleus of the animal cell. In bacterial systems, sialic acid can be also biosynthesized by an aldolase. This enzyme uses, for example, The mannose derivative as a substrate, inserting 3 carbon from the pyruvate into the resulting sialic acid structure. These enzymes can be used to chemoenzymatic synthesis of the sialic acid derivatives. Functions of sialic acids. Sialic acid containing glycoproteins bind selectin in humans and other organisms. Metastatic cancer cells often express a high density of sialic acid rich glycoproteins. This overexpression of sialic acid on surfaces creates a negative charges on cell membrane. This creates repulsion between cells and helps these late stage cancer cells enter the bloodstream. Sialic acid rich oligosaccharides on the glycoconjugates found on surface membranes help keep water at the surface of cells. The sialic acid rich regions contributes to creating a negative charge in the cell surface. Since water is a polar molecule with partial positive charges on both hydrogen atoms, it is attracted to cell surfaces and membranes. This also contributes to cellular fluid uptake. Sialic acid can hide mannose antigens on the surface of host cells or bacteria from mannose binding lectin. This prevents actions of complements. Sialic acid in the form of polysaccharide as polysialic acid is an unusual post-translational modification that occurs on the neural cell adjacent molecules. In the synapse, the strong negative charge of the polysialic acid prevents end-cam cross-linking of cells. Administration of estrogen to castrated mice lead to a dose-dependent reduction of the sialic acid content of the vagina. Conversely, the sialic acid content of mouse vagina is a measure of the potency of the estrogen. Reference substances are estradiol for subcutaneous application and ethylene estradiol or for oral administration. Thank you.